In our last video, we talked on multiplication of addition, subtraction, and multiplication of complex number, where we have z1, z2, z3, and z4. So, and when we did our addition and subtraction, we noticed that all we just have to do is open the brackets, okay, bring the real parts together and bring the imaginary parts together, and if there is a need for a scalar multiplication, then we do that, okay. And then in multiplication, we multiply all through, okay, by just like we do in polynomials, right? And then we end up having something like I squared, okay, I squared. So we go back to our foundation, where we say that our I is equals to square root of I minus 1, our I squared is equals to minus 1, and I cube is equals to minus I, and I raised to power 4 is 1. So in that sense, we substitute our I squared back into the equation, and once it is substituted back, then we can now simplify further, just like bringing the real term together and bringing the imaginary term together to be simplified. So we evaluated z1, z2, z3, z4, z2, z3, and then we ended up having z1, z2, z3, okay, which we solved in two different ways, okay. We solved that z1, z2 multiplied by z3, one was z1 multiplied by z2, z3. Now, since we did each and every one of them and found out that the answers were different, so multiplication is commutative, okay. So, and in essence, we can say that our z1, z2 can be written as z1 multiplied by z2, z3, or z1, z2 multiplied by z3, or z1, z3 multiplied by z2. Now, this was given as an assignment which will be which I believe you have solved, and your answer should be the same as minus 120 minus 10i. Yes. Now in this video, we'll now focus more on division of complex number. So we are still using our questions as of z1 is equals to 2 plus 4i, z2 is equals to 4 minus 3i, z3 is equals to minus 5 plus 2i, and then z4 is equals to minus 1 minus i. Now, in the division of complex numbers, we have to understand that we are going to be working with conjugates of complex numbers, okay, conjugates. Now, the conjugate of z1, okay, it can be written at okay, let's write it as the conjugate of z1 can be written as z1 bar, okay. Now there's like a bound of, okay. Now if the z1 is 2 plus 4i, okay, so z1 is equals to 2 plus 4i, okay. Now z1 bar, okay, will be equals to 2 minus 4i. Now all we are changing is just like where when we go back to division of vectors. Yes, all we are changing is the plus, the sign of the imaginary number, okay, the sign of the imaginary number. So we can also say further that if z2 is 4 minus 3i, then z3 is equals to 4 plus 3i, okay. All we are focused on is changing the sign at the center. Now if now I didn't record. And alright, so if I have z1, okay, we can start afresh. and we have z1 to be equals to 2 plus 4i, our conjugate of z1, that's z1 bar, will be equals to 2 minus 4i. All we are changing is the sign of the imaginary number. Okay, from if it is negative, we change it to positive. If it is positive, we change it to negative. Now, if equals z2 is equals to 4 minus 3i, so the conjugate of z2 will be 4. The sign here is negative, and it will become positive 4 plus 3i. If z3 is a minus 5 plus 2i, our conjugate of z3 will be minus 5. Okay, we are changing this interim sign of 2i, which is positive here, then to become negative minus 2i. And finally, our z4 is minus 1 minus I. Okay, then we are going to have a conjugate of minus 1. The sign here is negative, it becomes minus 1 plus I. Now, when it comes to division, let's say for instance we have z1 divided by z2. Okay, so our answer it becomes 2 plus, let's call it question 1, 2 plus 4i divided by 4 minus 3i. Now it looks partial. Okay, it looks partial, and all we have to do now is to the solution. The next step is to multiply the numerator and the denominator by the conjugate of z of the denominator. Okay, so the key that we are using is to multiply the numerator, okay, and denominator by the conjugate of the denominator. So in essence, z1 divided by z2 will be equals to z1 z2. We are going to multiply the numerator and the denominator by the conjugate of the denominator. The denominator is z2, right? So the conjugate will be what? Z2 bar by z2 bar. Okay, so now in essence, our z2 bar, remember our z2 bar is here, that's 4 plus 3i. So we multiply it by 4 plus 3i and 4 plus 3i. Now we can now come back here. Let's rewrite this to be here. We have it to be z1 divided by z2 is equals to 2 plus 4i divided by 4 minus 3i, multiplying the numerator and the denominator by the conjugate of the denominator. The conjugate of the denominator is 4 plus 3i because the denominator is 4 minus 3i. Okay, so then when this is done, we now bring them together. That will give us 2 plus 4i multiplied by 4 plus 3i divided by 4 minus 3i multiplied by 4 plus 3i. Now this brings us back to multiplication of complex number. So where we can simplify the numerator by simply multiplying it out, and also the denominator by also simply multiplying it out. Okay, now so multiplying them out again, we have 2 times 4 will give us 8 plus 6i, and multiplying by 4i we have 16i. Okay, 16i plus 12i squared, and divided by 4 plus 4 times 4 give us 16, and 4 times 3i, okay, we give us 12i. Multiplying this we give us minus 12i, and this give us minus 9i squared. Now in essence we have 8 plus 6i plus 16i. Now I want to substitute our I squared is equals to minus 1. Okay, plus 12 minus 1. Same thing for the denominator, and we can see that this cancels out this because plus 12i minus 12i is equals to 0, and we are left with minus 9 I squared. Now we are substituting I squared to be equals to minus 1. Okay, so in essence we have 8 plus 6i plus 16i. 12 multiplied by minus 1 will give us minus 12, and this will give us 16. Minus 9 multiplied by minus 1 will give us plus 9. So in essence, we bring the like terms together. So bringing the like terms together, we have it to be 8 minus 12 plus 6i plus 16i divided by 16 plus 9. So 8 minus 12 is minus 4, and 6 plus 16 will give us 22i divided by 25. Now we can easily split this. Okay, that will give us minus 4 divided by 25 plus 22 divided by 25i. So this will give us an expression for z1 divided by z2. Okay, let's explain further again. Okay, using this is z3 divided by z4. Okay, now to solve this, we are going to multiply the numerator. Okay, remember the key. Okay, the key is to multiply the numerator and denominator by the conjugate. Multiply numerator and denominator by the conjugate of the denominator. Now, if we look at this now, the denominator is z4. Okay, and the conjugate of the of z4 is z4 bar. Okay, now, so we are going to multiply the numerator and the denominator by the conjugate of the denominator, that's z4 bar. Okay, now what is z3? Our z3 from the question is minus 5 plus 2i, minus 5 plus 2i, and our z4, okay, is z4 is minus i, minus 1 minus i, minus 1 minus i, and our z4 bar, okay, like we have done here. If you look here now, look at this please, we can see that our z4 bar is minus 1 plus i, because we are changing the interim sign of the imaginary part. Okay, so we multiply it by minus 1 plus I, minus 1 plus I. Now, with this understanding now, we can now open the brackets seamlessly because we've done various examples on it, and we have this multiplied by this. Okay, it brings us to a format we are familiar with. Okay, now we open the bracket with multiply with minus 5, okay, plus 2i, minus 1 plus I, divided by minus 1 into minus 1 plus I, minus I into minus 1 plus I. Now, having this done, we now multiply. Okay, we take a bit and multiply 2. This will give us 5. Multiply again. This will give us minus 5i. Multiply this. Okay, this will give us minus 2i. Multiply this, and this will give us plus 2i squared. Okay, we perform the same operation, multiplication operation, at the numerator, just like we've done. We'll do it for the denominator. So this will give us 1. Okay, minus 1 times minus 1 will give us 1. Minus 1 times I will give us minus I. I times minus I times minus 1 will give us plus I, and minus I times I give us minus I squared. Okay, so having done this, we can see that minus I and plus I will turn out to give us 0. So in essence, we are left with 5 minus 5i minus 2i plus 2i squared is equals to I minus I squared. Okay, Now we call that I is equals to square root of minus 1. I squared is equals to minus 1. I cube is equals to minus I. And I raised to power 4 is equals to 1. So all we want to substitute is I squared. Okay. Now we substitute I squared to be equals to minus 1. So it equals 5 minus 5I minus 2I. Wherever we see I squared, we substitute it to be minus 1 divided by I minus I squared minus 1. Okay. Then we simplify it further. So this is 1. Apologies. Okay. 1, 1, 1. So 5 minus 5I minus 2I. 2 multiplied by minus 1 gives us minus 2. And this will give us 1 plus 1. Okay. So we collect like terms, bring the real parts together and bring the imaginary parts together. So this gives us 5 minus 2 minus 5I minus 2I divided by 1 plus 1 is 2. So this gives us 3 minus 7I divided by 2, which can also be written as 3 over 2 minus 7 over 2I. So this will give us Z3 divided by Z4. Okay. Now, in a moment, we'll take another example. So take on Z2 divided by Z3. Okay. And you can pause the video right there and try and solve it before I go ahead. Now Z2, okay, divided by Z3. So we have it to be Z2 multiplied by Z divided by Z3. And we are multiplying by the conjugate of the denominator. Now the conjugate of the denominator is Z3 bar Z3 bar. Okay. Now Z2 is from the question. From the question we have Z to be 4 minus 3I. Z2 to be 4 minus 3I. And Z3, okay, Z3 is what we have here. That's 5 minus 5 plus 2I. And the conjugate of minus 5 plus 2I will be minus 5 minus 2I. Minus 5 minus 2I. So then we multiply out. So this will give us 4 minus 3I multiplied by minus 5 minus 2I divided by minus 5 plus 2I multiplied by minus 5 minus 2I. So in essence, we have it that when we open the numerator, we have it that it is 4 into minus 5 minus 2I and minus 3I into minus 5 minus 2I divided by minus 5 into minus 5 minus 2I plus 2I into minus 5 minus 2I. So we perform this multiplication process by opening the brackets bit by bit. So open brackets with 4. In this case, we have it to be minus 20. And multiply this, we have it to be what? Minus 8I. And when we multiply this, we have plus 15I. And when we multiply this, we have plus 6I squared divided by, multiply this, we have 25. This multiplies by this, we have 10I. This multiplied by this, we have minus 10I. And this multiplies by this, we have minus 4I squared. So having done that, we have it that our 10I and minus 10I will cancel out to give 0. So we have minus 20 minus 8I plus 15I plus 6I squared divided by 25 minus 4I squared. Now we recall that I squared is equals to minus 1. Then we substitute our I squared. So we have minus 20 minus 8i plus 15i plus 6 into minus 1 and 25 minus 4 into minus 1. So this will give us minus 8 minus 20 minus 8i plus 15i minus 6 divided by 2, 25 plus 4. So to solve the numerator, we'll bring the real parts together, we'll bring the imaginary parts together, just like bringing like terms together. So we have minus 20 minus 6, and we have minus 8i plus 15i, everything divided by 29. So minus 20 minus 6, we have minus 26 minus 8i plus 15 is 7i divided by 29. So this can be written, we can leave our answer like this, or we write it as minus 26 divided by 29 plus 7i over 29i. Okay, and this will be z2 divided by z3. Okay, now we have been experiencing some things lately such that when we multiply, okay, let's start from the first one. When we multiply complex number with its conjugates, okay, and our result at the denominator is just a real number, okay, when we multiply z4 with its conjugate at the denominator, our result is just a real number, okay, 2, okay, and z3 multiplied by its conjugates, our result also was just a real number, 29. Now what's that? So let's analyze that. So let's say we have a complex number of, say, z is equals to x plus yi, and obviously the conjugate will be to change the sign here to negative, so it's z minus yi. So now we want to multiply z, okay, multiplied by the conjugate of z. That will give us x plus yi multiplied by x minus yi. So opening the brackets, we have x minus yi plus yi into x minus yi. So this will give us x squared minus xyi plus xyi minus yi squared. Y squared, I squared. Okay, because this will multiply this, this will multiply this, this will multiply this, and this will multiply this. So we can see that this is similar to this. So the two of them cancel out to give 0. So we are left with x squared minus y squared, I squared. Now recall that I squared is equals to minus 1. Let's substitute value of I squared. So we have that x squared minus y squared into minus 1. So we have x squared minus y squared multiplied by minus 1 will give us plus y squared. So the product of a complex number with its conjugate is the sum of the squares of the real part and the imaginary parts. So if we work on this that we have so far, okay, so if we copy this, let's try and copy this, and let's now perform the product of its conjugates with the other. Now let's perform z1 multiplied by z1 bar. Okay, so we realize that it is the square of the real part. The real part is 2. Okay, so that is 2 squared plus the imaginary part, which is 4. Okay, plus 4 squared. That will give us what? 4 plus 16, and that will give us 20. Okay, now the same thing applies here. Z2, Z2 bar. Okay, it will be the square of x, that is 4, and the square of y, that is minus 3. Okay, so this will give us 4 squared. 4 squared is 16. Okay, and minus 3 squared is 9, and this will give us 25. Now we can see that we have z2 and z2 multiplied by the conjugate of z2 to be 25, and which was the same operation we carried out in the first example, okay, where we have z2 multiplied by z2 bar, right? And our answer was 25. Okay, so instead of going through the whole process of multiplying out as we have here, and then we substitute our I squared, we can easily just perform our x squared divided by x squared plus y squared for the conjugates. So if we do for the rest, we will see that our answers are similar. Z3 bar, so it will be minus 5 squared plus 2 squared. So this will give us 25 plus 4, that will give us 29. And Z4 bar give us minus 1 squared plus minus 1 squared. That will give us 1 plus 1 that will 2. Okay, now in the same vein that let's look at something much more interesting. In the same vein that we had Z1, Z2, Z3. Okay, we can also have Z1, Z2 divided by Z3. Okay, now we can call this question 4. Okay, and it will be our last question for this video. Okay, now Z1, Z2 divided by Z3. Obviously the rule still stands. Okay, we are going to multiply the numerator and the denominator by the conjugate of the denominator, and since the denominator is z3, the conjugate is z3 bar. Okay, so we multiply the numerator by z3 bar and we multiply the denominator by z3 bar. So having done that, then we have to evaluate our z1, z2. Okay, and since we know z3, that's good. Now since we have evaluated z1, z2 before in our previous video where we talked on multiplication of complex number, and here we saw that our z1, z2, let's check, we realize that our z1, z2 is 20. Okay, 20 plus 10i. We solved it before to give us 20 plus 10i. 20 plus 10i, and our z3, as we can see, is minus 5 plus 2i, minus 5 plus 2i, and the conjugate of minus 5 plus 2i will be minus 5 minus 2i, minus 5 minus 2i. Now having done this, we can also have we will now multiply out. Okay, so this will be 20 plus 10i multiplied by minus 5 minus 2i divided by minus 5 plus 2i multiplied by minus 5 minus 2i. Now you can simply do your multiplication. We can simply do our multiplication rule, but let us apply what we have learned, that the product of a complex number, let's say z, multiplied by its conjugate z bar, is equal to the sum of the squares of the real part and the imaginary parts. Okay, so we are saying z is equal to x plus yi. Okay, now we can apply the numerator and multiply out. That's 20 into minus 5 minus 2i plus 10i into minus 5 minus 2i divided by, since this is z3 and this is z3 bar, we can easily apply this rule. Okay, and z3 multiplied by z3 bar will be the product, the squares of the real part, that's minus 5 squared, plus the imaginary part, which is 2 squared, can also be minus squared. Anyone? 2 squared and minus 2 squared is the same thing. So we have 20 multiplied by minus 5. It gives us minus 100, and 20 multiplied by minus 2 give us minus 40i, and 10i multiplied by minus 5 will give us minus 50i, and 10i multiplied by minus 2 will give us minus 20i I squared. Okay, so this will give us 25 plus 4. Okay, so instead of we have cut down short our solving. Okay, so we all we just have to do is substitute our I squared to be minus 1 in the numerator only. So this will give us minus 100 plus 40i minus 50i minus 40i minus 50i minus 20 into minus 1 divided by 29. So this will give us minus 100 minus 40i minus 50i plus 20 divided by 29. So in essence, we can bring our real terms together. That's minus 100 plus 20 minus 40i minus 50i divided by 29. So this gives minus 80 minus 90i divided by 29. It gives us minus 80 divided by 29 minus 90 divided by 29i. So this is z1, z2 divided by z3. Now, questions can come in and be in any form, and I wanted to try it. So we have z1, z2. We're gonna be divided by z4. Okay. We can also have z1, z4 divided by z2, and we can also have z1, z2, z3, like we have evaluated before, divided by z1, z2. The rule still stands. Okay, all we just have to do is to multiply the numerator and the denominator by the conjugate of the denominator. Let's take for instance this third question here. Z1, z2, z3, okay, divided by z1, z2. It might look a bit complex, but let's go back. Now the first thing we have to do is to evaluate z1, z2, z3. Okay, and we have done that in our previous video, where z1, z2, z3 is equal to minus 120 minus 10i. Okay, so we apply that here. Z1, Z2 is minus 120 minus 10i, and our Z1, Z2, okay, is 20 plus 10i, 20 plus 10i. Now we can see how a complex question is reduced further into a simple complex number division. So all we just have to do here is to multiply the numerator and the denominator by the conjugate of the denominator. Now the conjugate of the denominator, okay, is, since this is plus here, this is our denominator here, okay, this is our denominator here. Since the sign at the of the imaginary part is positive, then definitely our sign, it will change to negative for the conjugate. So we are multiplying by 20 minus 10i and 20 minus 10i. Okay, so in essence, all we just have to do is to multiply the numerator 20 minus 10i minus 10i into 20 minus 10i, and this will apply our product of conjugate and the complex number itself. So it just becomes 20 squared, okay, and plus 10 squared. You can as well just follow the normal. You can as well just follow the normal multiplication process. So let's do this in 2 minutes, okay, and we'll wrap up on this video. So minus 120 multiplied by 20 give us a minus 2000, quite a large number, 400, and this will give us plus 1200 or 1200i, okay, and we can also have this to be 200i minus plus 1000i squared, and 20 squared is 400 and 10 squared is 100. Okay, so in essence we now want to substitute our I squared. Okay, so we substitute our I squared to give us minus 1, so we have minus 2 for 2400 plus 1200i minus 200i plus 100 into minus 1. 400 plus 100 will give us 500. Now we have minus 2400 plus 1200i minus 200i minus 100 divided by 500. Now to solve the numerator further, we bring the real parts together and bring the imaginary parts together. So we have 24 minus 2400 minus 100 plus 1200i minus 200i divided by 500. So this will give us minus 2500 plus 100i, 8000i. Yes, everything divided by 500. So we have minus 2500 divided by 500 plus 8000i divided by 500. So in essence, minus 2500 divided by 500 give us minus 5, and 8000 divided by 500 give us 2i, give us 2. Okay, so we can see how everything was simplified further, and we know that this is just an expression for z1, z2, z3 divided by z1, z2. Okay, now we notice something. Now even this question, we shouldn't have even gone through this whole process. Okay, because if you look at this now, z1, z2, z3 divided by z1, z2, and we can say that z1 and z2 can cancel out, and our answer will be z3. And from our question initially, okay, this is just a confirmation, as we can call it, and our question initially, which is z3, we can say that our z3 is minus 5 plus 2i, and which is the same answer we got, right? Minus 5 plus 2i. So you can put yourself to test, okay, and see that you can generate questions on yourself and a lot of things, and to test yourself on addition, subtraction, multiplication, and division. Okay, and you can use as well use your calculator to confirm your answers. So in our next video, we're going into another format of complex number, which will be the polar form of complex number. So we'll see how we can convert the Cartesian form to polar form, and we can also perform some examples, okay, from the Cartesian to polar form, and we can also perform polar form to Cartesian form. So see you there.